It'll cost you $2,000 a panel to print it. So you could print a mansion at very high cost. So the only way this is practical, and that's what we want to do, is in the next few days is to do the shredder and filament makers. And the way to do it such that it's practical for just about any plastic waste stream is you'd need some high temperature chamber. So a regular chamber, you can't print nothing with without an enclosure, heated enclosure. You can't print nothing in general. It's like you'll print like 1% of the available plastics. Well, I actually don't know what the actual percentage is, but we know that things like some of the most common plastics, like polyethylene. Polyethylene, I believe, is the most common plastic. You can't print that.
And like heating it through the nozzle, it melts at the nozzle, but then it has to stay hot once it's.
Yeah, you can't have thermal gradients between parts.
Otherwise, it
Actually,
doesn't stick properly.
Well, it will warp.
It'll warp.
It will warp, delaminate.
Yeah.
Now, so the entire chamber has to be close to the actual melt temperature. So if you're doing like, like as close to it to the point where it's stable and not melting into a glob. That's the idea. But I mean, if you have any experience with printing, like if you try to print with ABS, I mean, yeah, you could. People say you can print with it, but maybe like small parts, like close to the bed where it's heated. Once you get up or try to print something thin, it'll just fall right apart. You're not doing anything with ABS. So for practical purposes, you can't print with anything but there's PLA. TPU does print well without a heat chamber. Like I did some of those belts and things. That does print well. And there's a few others that may print well. What else prints well without a chamber? I can say TPU and PLA. What else?
What about rubber?
That's thermoplastic urethane rubber.
Ah, okay.
Yeah. But beyond that, I can't really say much. Maybe PVC, maybe, I don't know. Not a lot of people print with PVC, but definitely not anything like polycarbonate. You don't have ABS, you don't have this material, PEI, you can print that too. Forget about polyethylene, polypropylene, which are super common. So we need a heated chamber. So the idea is to build, it's like building two things, building two frames. One is the frame for the printer and one is the frame for the chamber. And a chamber could be a simple thing. It could be I think the easiest way to do it is, I would actually do rebar for the inner chamber, I would do angle for the outside chamber. The angle, angle frame, so we got the 1/4x4 angle,
How
1/4 inch.
How hot is the inner chamber, the heating chamber?
Yeah, the heating chamber is not a lot, it's up to 180
So
Celsius.
Celsius.
Foam panels, right?
Foam?
Yeah.
Not foam.
How
You'd
about
want to do fiberglass or rock wool for insulation. So we could do what I would propose is we take the house insulation, which we got big bats of, and we got a lot of, just do that.
I
That's
mean,
not
if
going to
it's-
melt anywhere with 180 C. So
I'll think of it in a minute.
yeah. So as far as the extruder itself, it's the same thing. Same thing. Gets you 5 pounds per day of printing, which is not a lot, but you can also do. One thing you can do to increase that is you can put a lot of heads on this. So like 2 heads, 4 heads, 9 heads. Well, I don't know if we're gonna have time for that. Let's try with one first. But if you got 9 heads on this, and that's you can print, like say you're printing like 2x4s, whatever. That's completely practical. So context is completely practical printing. Like say you got to print a bunch of lumber, plastic. Like for example, for the aquaponics, like that takes into consideration areas where you got wetness. So anything like aquaponics, like for example that aquaponic greenhouse, the wood is rotting and you can't really have treated lumber by things you're growing. So things like that, it becomes really practical for wet environments. The equivalent of treated lumber, except it lasts longer. Like treated lumber is supposed to last like 20 years or so. But this is but this is more like, as long as you keep UV away from it, you're good. Or you can do UV stabilization too. You can do additives. Some plastic regrind is already UV stabilized and all that.
I guess you paint
So-
it too.
You paint it, but paint We did paint ours, so that doesn't do much for wet environment if it's like in an aquaponic greenhouse.
No, I mean, paint the plastic so it's UV
Oh, you
stable.
can, you can paint the plastic outside coats or just throughout, so you get pretty much infinite lifetime. For practical purposes, things like foundation forms, say you want to do like a post, typically which they do like a sonotube, that, but they don't provide in the market, they don't do things where, because you always have to have like a pad on the bottom, so say you do a post that's 6 inch, but you have to have a wider pad. You can print forms like that, for example, that would be a great application, so you dig a hole and stick this 3D printed form, which otherwise is pretty hard to do. You have to do a lot of messing around trying to hold it up and all of that. Things like foundation forms, like ICFs too, like insulated concrete forms, are a thing where you have multi-layer bubbles or lamination, like basically, what do you call it, honeycomb structures. You can print that with 3D printing. That would be for insulated things, like Imagine panels that we actually start doing insulation in it. For larger things like entire tractor tires or tracks, that's practical. But all of this is nothing without having the shredding and filament making, because you're talking about $2,000 a panel otherwise, or like a lot of money, just not different than the regular marketplace, and in places much more expensive. So that's the deal. For us right now, it's pretty easy to make a large frame. We can do that, but there's technique. So no running away into your world. Build on my experience. We've done a lot of this. So we can do that pretty easily. The 1-inch universal axis, that's the challenge there. So what is the challenge here? We've got 6 printers. We would have liked to have 12. That's where I would suggest actually doing, we can easily do things out of wood, but we got to jig it and get precise. Like when you have the rods, the idea is the rods have to be parallel, so you have to have precise spacing. But it's not hard to simply get a wood block, put in the 2 holes for, like, okay, so here, take idler. What is that? It's just a block. It's got to have 2 holes for the rods and 1 hole for the idler. That's it. And then a hole, of course, so that you ream that out for the belt. I mean, it's simple stuff, and we should do it. Now we've got carpentry skill in-house. We should definitely take advantage of that.
Beautiful shop, wood shop. It's amazing.
So that could augment that. What about some harder things to, like what's harder in the geometry? Well, a lot of these things,
Say again the temperature for the chamber.
180, but
180.
none of that, so here's the deal.
So-
None of the sensitive parts.
Polyurethane foam would be good.
Okay. Yeah. The way it works is that, so I should get on the computer to show that, but the way it works is that, so that it's a 6-axis, 7-axis printer, so 4 Z's, 2 Y's, 1 X. So 4 Z's because we got some heavy weight.
Do you want to put it on the screen or something so we can visualize a little better?
Yeah.
Sounds good.